All right, I received a request from a student, and I'm going to do this a little bit differently. So the region is bounded by the function y equals e to the x, and if you think about that function, it's an exponential growth because the base is positive and bigger than 1. Okay. We have a vertical line, 2 vertical lines, so I'm going to save that for last. And then a parabola, y equals x squared minus 1. So you should remember, it looks something like this. Okay. And x equals 1 and minus 1. So my region is right here. So if I take a rectangle, let me just draw a rectangle there. And I take it out. If you think about it, my top function is e to the x. My bottom function is the parabola x squared minus 1. So the height of this is my top function minus my bottom function. So my area integral is the integral from -1 to 1 of my top function minus, and I'm going to distribute the negative, and there's the first. Now what I'm going to suggest, now you want to think about, we can anti-differentiate all of these and it's not bad. However, what we want to do, I'm going to use the property that the definite integral of a sum or difference is the sum or differences of the definite integrals. Okay. And actually, there's something else I can do here too if I really wanted to. Okay. If you look at this second and this third integral, yes, every one of these integrals has a symmetric interval, -1 to 1, but that's not the important part. This integrand is even, which means the area from -1 to 0 and 0 to 1 are the same and the same sign. Likewise for this constant function. Okay, but I'm just going to leave this alone because I see a rectangle. So this is e to the x, antiderivative. Okay, we're going to 1/3 x cubed. Okay, and okay, the height is 1, and the distance, is 1 minus -1. So I'm going to use the idea that this is a rectangle. So this is e minus 1 over e. That one wasn't so bad. Minus, okay, this is 1/3 times 1 minus, but -1 cubed. When you cube -1, that becomes -1. And 1 minus a -1 becomes 1 plus 1, or 2. Minus, and 1 plus 2, that's just going to be 2. Okay. So e minus 1 over e minus 2/3 minus 2. So is 2, I think 2 is still 6/3. Someone needs to check my arithmetic. So this is e minus 1 over e, okay, minus, and I believe I added that correctly, and that would be square units. Okay, now let me pause it for a sec. Sorry about that, I had to run. I noticed something when I sat down. Notice I copied something down wrong. See right here, this is correct, so this is plus. Okay, so this is plus, so this is plus 2. So that means I got to fix this. So let's just draw a line through this, and let's fix this. So this is still going to be e squared minus 1 over e. Okay, that's not so bad. Then we're going to subtract 2/3, but then I believe 6/3 I'm going to add, so that's going to be e squared minus 1 over e plus 4 over 3. Now I could do some arithmetic and make that look, and that's going to be in square units. Okay, now let's check this. So open up your browser. I'm going to use GeoGebra. So I went to geogebra.org. I typed in f of x is e to the x, and g of x is x squared minus 1. Now, one way I could do this is I'm going to integral between, I come down here, between the functions, function and function. Okay. So function f, function g, we started at -1 and we go to 1. And, oh, you know what? There you go. Okay, that's one way you could do it. Now watch, I'm going to turn these off. And I'm going to say, I'm going to want the integral. Actually, let's do this first. My height function was f of x minus g of, you know, you gotta love it when these pop-ups come, right? Minus g of x, okay, and I want the integral, okay, the function's name is h, and I'm gonna go from, okay, it's not letting me, okay, -1 to +1. Now, notice the values are the same. So I've checked it two different ways here. Now, one thing you may want to is when you're defining this, if you want to make it look right, you know, you could be pristine and say h of x, and now it says h of x, okay? But now let me turn this off. But now look, h of x, here's this function that's the difference of f and g. Notice that when I do that difference from -1 to 1, it's non-negative, and we're back to what we did in the beginning of calculus in Calc 1. Now, I'm now going to adjust this, and what we're going to do is the trapezoidal rule, and let's do a trapezoidal rule of 5 equal width non-overlapping subintervals. Okay, well, let's think about this. Now, and then we're also going to do a table, and we're going to do a bunch of things so you can practice. So here's what we're going to do. We go from -1 to 1, and this was e to the x minus x squared minus 1 in x, and I need another parentheses. So delta x is b minus a, 1 minus -1 over n, and n I said was going to be 5. So 1 minus a -1 is 2, so it's going to be 2/5. This is going to be 4/10. So we're going to start at -1. -1 and 4/10, well, then when I add them is -6/10. I add another 4/10 to that, -2/10. I add another 4/10 to that, oh, that better be +2/10. I add another 4/10 to that, that's 6/10. And then finally 1. So notice the left endpoint, a, which is x sub 0, then x1, x2, x3, x4, x5. Now, here's what we're going to do. If my memory is correct, it's 1/2 the height. The height is right here. It's delta x, so that's 1/2 of 4/10 times. Now, let's make this, we call it h of x. So let's use h of x is equal to e to the x minus x squared plus 1. So this would be h of -1. And there's one of them because it's in one trapezoid. Now I go to the next one. I'm going to use 2 of them. And the reason I'm using 2 of them is that height is in 2 trapezoids. Then I go to the next one. That's h of -2/10. And there's 2 of them because that's in 2 trapezoids. And then I'm going to go 2 times, h of 2/10 because that's in 2 trapezoids, 2 times h of 6/10, and finally 1 times h of 1. And why am I going to do that? Why is it only 1 times this last value? Because this first endpoint and this last endpoint are only in the one trapezoid. This is in the very first trapezoid. This is in the very second. So this is in the first and second trapezoid, the second and third trapezoid, third and fourth trapezoid, fourth and fifth trapezoid, fifth trapezoid. Now that's set up. Now what we're going to do is we're going to get out our GeoGebra. Okay, I'm going to turn this off. Okay, and I'm going to extend this so I can see things. Now I'm going to do this. Now when you do calculations, h of -1, then I'm going to add 2 times h of -6/10. Oops, I got to delete that. I don't want a fraction there. I hit a division and I don't want to do that. 0 and 6/10 plus 2 times h of negative 0 and let's see, we're at 2/10. Now we're going to add another 2 heights because we're into the next trapezoid, and that's h of 2/10. Okay, then we're going to add the last height that's in true trapezoids, h, oops, not small h, not big h, of 4/10. No, 6/10. I almost added the wrong number there. Okay, 6/10. Don't you love it when technology fails? And then finally, we're going to add 1 times h of, don't capitalize it, 1 of h of 1. And I'm going to hit enter and see what happens. Okay, let's see here. Let's make sure I haven't. H of x is f. Okay. Hey, what's. Whoa. I don't want. Okay, let's just redo this. And it's good that you see that mistakes happen and we have to start over. Okay, h of negative 1. Okay, plus h, h of negative 6/10 plus 2 times h of negative 2/10 plus 2 times h of 2/10 plus 2 times h of 6/10. And finally, I'm going to add 1 times h of 1. Okay, now notice what happens. So this says the sum of all those functional heights is 18 and some change. So watch what I'm going to do here. Oh, I have to change a couple things. I didn't put the approximations. Half of 4/10 is 2/10, so I'm going to do that. And now I'm going to go and show you what I'm going to write on my paper. And let me show that to you now. Oops, that's the wrong one. Just kidding. So now half of 4/10 is 2/10. So now I'm going to multiply these together, and that's my trapezoidal sum. So now notice they're calling it C. So I'm just going to go C times 2/10 and 3.66165, blah, blah, blah. There you go. Now let's set up a table of values. Trapezoidal sum. Okay. Function h of x. Where does it start? Negative 1. Where does it end? 1. And we did 5 trapezoids, right? Oops, not 15, sorry. Let's see. Okay, 5 trapezoids. Okay. And now check your answer. And do you notice it's the same as what we just had? Now all I'm going to do is, I'm going to make a table of values. I'm just going to come up here now. I'm going to change 5 to 10 trapezoids. Notice it went up a little bit. 6, 7, 8, 2, 3. 10 trapezoids. But technology, let's do 100. Okay. If I add 100, 3.6836 ... Now, let's do this. The value of this integral is in line B. So I'm going to go B minus C. If I do that, right, did I use the right line? Yes, I did. You can see they're off some, right? Well, what happens if I change this to 10? Okay. Right? So it's changing some. It's deliberate. It's methodical. And now let's go. And you should be able to use the technology. But notice I verified it before I used the command and just generate it all. Now, if you're using a scientific calculator, it's going to take a little bit more time. Now, I'm going to stop this video. I'm going to reboot this video, and then we're going to do Simpson's method.